We're going to call now Professor Paulo Roberto de Carvalho, and we're going to ask the table to all the participants to come back to the table. Professor Paulo Roberto Carvalho is graduated in industrial chemistry and master's in work safety. He is Doctor of Sciences by Fiocruz, and he is a research professor in the Polytechnical School Joaquim Venâncio.
Good afternoon, all of you. It's a great pleasure that I'm here with you. First of all, I'd like to thank Professor William for having invited us to participate and to congratulate the coordination of the event. That certainly today we are going to leave this room knowing a little bit more, many doubts because of the complexity of the theme, but it is a motivating theme. It's wonderful. Time goes fast, and we don't feel it. Yesterday we had to be kicked out of here, otherwise we'd stay here the entire night. I would still be very happy to be here longer. So we have a challenge. It's a big challenge. Excuse me. I would like to congratulate the speakers for the excellent presentations that we have watched. I would like to thank and congratulate our coordinator at the table here. And I would like to ask the panelists, you may or may not answer, but let's hear it. I have a big concern, perhaps because of my area, it's biosafety, with the quality of the professionals that will go to labs and work in labs. I'm talking about students, interns, not the quality of their education, which is excellent, but the issue of learning about safety, the necessary notions to protect themselves, to protect property, protect the environment. And something that's very important is the issue of the quality of being able to reproduce an experiment. Sometimes it's difficult. And in view of that, I would like to just say, I'll change this several times, but when the new technology knocks at our doors, or better, the new technology have their hands on the doorknob, is entering, it's not knocking anymore. Perhaps it's time for all educational institutions together with scientists to rethink the content of the courses in order for us to have a focus on the issues of environmental security, for instance, so that we can train excellent scientists. So this is the question I want to leave with you, so please you may answer as you wish. I would like to make a comment. I think it's very important observation. The values of APJ is the School of Engineering that are close to engineering. We have great possibility of doing this exchange. And when we have students over there, it's something very clear. The workload is very heavy in the different courses, especially if you go to Germany, to France. They are slightly lower per course. So we have a lot of work for the students, and it's something that we have to rethink. So when we think that that engineers have a job, no doubt, all of them they're well trained. The ones in UFRJ, they also have a job, no problem there. But we have to rethink our course, It's not enough to just follow these models. We have to rethink, it, well, are our models correct? The model we have, the Federal University of Rio de Janeiro, is correct. More than 80% of a course has to be required disciplines. Couldn't we allow the students to have a more eclectic, more chosen by themselves type of formation, a type of education? We have to have such a workload in the classroom, or perhaps this is a time to get the students and make them aware of their own choices, of their profession, from the first period that they are in schools. Like a student, sometimes the fourth period is extremely childish because they're always in the classroom. So I think we have to start looking at our students in a different way, because we should give the space to the student so that have all of the notions of safety, so that in order that we can train people that are able to think. And I think this is the challenge of the new universe, the challenge for the engineer of 2020. It's a challenge for the nanotechnologists, a person that's able to think more than simply to do well in tests and observe the information that we give, because the information we give is not enough. Thank God the world is changing. First was a solid. I forgot that there was a portrait. It's a slide that I skipped that pointed to some things, and in fact Renata mentioned it. We spent a long time in the classroom in Brazil. We have a vision that prioritizes the content or the sum of contents. And the worst example comes from my area, from physics. Because we are in 2010, and the physics that's taught at the middle school has finished over a century ago. And the education in basic physics, it was done 60, 80 years ago. How is this done in a traditional manner? I just add disciplines. For instance, physics 1, in 11 of 10 schools that have this different schools. Why don't you start with relativity? After one semester, give the big ice cream as a nickname of that, it's the ballistic movement. Why don't we start with relativity? Because restricted relativity, you have to know the Pythagorean theorem and those square roots. It's not that difficult. Why don't we dare and go straight to relativity? So this is the type of question that I ask myself. We spend too long in a classroom. We are extremely condescending with the students. When we're talking with Renata here, why don't we see in other places less time? I always heard from my colleagues, that's because in our reality we have different students. So it goes back to what Pelé said years ago, saying that Brazilians are not ready for voting. That's the same demeanor. So I'm taking 20 years to be able to face that, to be able to voice these concerns of mine. Yeah, I would like to add to that, because I believe one of the causes of all this condescending to learn mechanics in Physics 1, it happens in the middle school, that's in the elementary school. That's the greatest problem here. If the teachers from the middle schools were here to understand and to acknowledge the importance of these details for the students in the middle school about biosafety or safety, to know how to deal with the technique, how to deal with the sample without having harm to your health. So this basic instruction. So our university is a continuation of the middle school. It's a paternalistic system. We have to teach them everything again, because their training is totally different among the students. If they came with a training a lot more solid, so in this room here we should have a great number of middle school teachers, because we have to, they come to universities not knowing enough. They don't know, like if they give a little pot with carbon nanotubes, he doesn't know that it's very dangerous to breathe that stuff, you know. So I think this undergraduate could be much more efficient if at the basic level the teachers had the knowledge of these details, the importance of this theme. In physics we have professionals, they have to come up with a product. And a good part of the product texts nanoscience, modest attitudes, but take to the classroom the important topics of our day-to-day. This is my contribution, and I agree fully with you, because the lack of maturity of students in laboratory is shocking. They do not know how to extract data. They don't question. They have no notion of order of magnitude. This is the common. The exception is the opposite. Whoever understands what he or she is doing. So that's what I have to say. So let's hear now your questions. I would like to start with Rio Grande do Sul, but we are talking about Unicamp, with the Federal University of Rio Grande do Sul, and PUC of Rio de Janeiro, all good institutions. So what about the other universities? These are your students we're talking about. It's it's very important. We talk about universities, like the best universities in the country. I work fully with the issue of the middle school. We have middle school again when we go into university. It's seen as, from the scientific mathematical point of view, is that a youngster of 16, 17 years old, a youngster of in the south. I'm sorry, he's talking too close to the microphone. It becomes very indistinct what he's saying. But we're talking about formal students. I think the opposite is very important as well. That workload that Renata mentioned, it's always, traditionally, in the last 30 years, the student has always been very proud of they don't know anything. We have to repeat the high school. Then 5 years later, they get their degree in the universities, and they end up having a better education. I thought it was a very strange type of magic. How can you be stupid, and 5 years later he knows everything? That's magic of the system. It's I'm sorry, there's a problem with the microphone. I can't understand what he's saying. It's well, has been an improvement anyway, but it's some kind of magic that happens there. So we have, like, because of the situation, we have physics of 100 years ago, and they forget with 70 years. I don't know if that has something with our dictatorship, because during dictatorship we couldn't study story of the 20th century. That was very dangerous. I don't know if there's some kind of impregnation. Since we don't study history, let's not study physics, let's not study chemistry or physics of the last 40, 50 years. Now, the Portuguese physics scientist, John Margueixo, he would think that if he remained in Portugal, he would have the same condition when he went to England. And then they said no. And his critic was, no, the problem is not the country, it's the structure of education that does not allow you to be someone who asks questions, because when you ask questions, the logic is shut up. Now, when you look at Feynman, he says in his biography, this our culture, he says that typically when he was here in Brazil, that he found it very strange that a student that questioned, that was pinched by whoever's on his side at the time, is shut up, don't say anything. So if you make the questions, you were the pain in the neck and you had to shut up. And he said, I never saw that. And then he started to understand, and he questioned that and observed, and he perceived that in reality there is a certain farce of you pretend that you study, you pretend that you're learning, and then you go ahead forward. And at any rate, I believe I didn't see two questions here. In one or another syllabus, and of course I would like to look at the syllabus, sometimes you have one discipline that's an impact. It appears to me that it should be a design of a project in terms of engineering. And in reality, I thought it was very interesting this parallel between engineering and nano, because engineers, they sometimes feel they're going to lose space for the construction of objects because of the physics scientists, so we're becoming new engineers in that scale. Or chemists, everybody is building these different things in small scale. But it appears to me that when we do design our projects, when we design the initial project, that's when we have to think of the potential of impact. So when you work a project, you don't have to think about the direct functionalities, but the lack of functionality, this functional side of the project, besides their use and potentials. So this is something that perhaps it's very important, not to have the disciplines. I believe it's important because the impacts, but it's absolutely impossible to have just one discipline that will deal with the environmental impact of 355,000 types of different materials. It's illogical. So when you enter this discipline, you actually should relearn to think on the conceptions for these possibilities, and in fact to broaden the possibilities. So that's just a little bit of what I want to talk to you, and I want to learn about your opinion about what I just said. First, I would like to give information to Professor Anaíra. For us, from the network of technology and nanotechnology in São Paulo, we had 4 cycles of information for teachers in middle schools, together with the teachers' trade union of the state of São Paulo. We had like Saturday classes for 8 Saturdays in which teachers had information about nanotechnology, the most varied aspects, and they got a certificate that allow them to get a few points to be taken into consideration in the process of the distribution of classes or whatever. So this was at the information level, not at the level of education. So we try to do that because, let's say, we have as an objective to take the nanotechnology to the known, to the layman, to the public in general, and among them, teachers of middle schools and high schools. So my questions uh, to you, except for Peter, because I will talk to Peter more directly in terms of multidisciplinarity. And here's my modest contribution for you that are course coordinators. You knew how to put this together, you know what the difficulties are. So, my question is, if there is no change in the course that you are initiating, in 5 or 10 years they will be consolidated in this form, and they're going to be just like the others, impossible to change. So, my suggestion is that we change things right at the beginning when it's possible to do. What's the central issue here, in my understanding? If you put biology, physics, chemistry, this is not multidisciplinarity per se. I don't have time to explain what I'm trying to say, but it's my understanding. But the quote I use is the sum of the parts is not the same as the whole. So effectively, like Peter said, multidisciplinarity implies in a new epistemological posture in terms of this production of knowledge in this educational process. So my modest suggestion, so it is, if it is possible for you that at the beginning of the course to think in these terms. In terms of the question of the professor, do you feel comfortable to answer it now? Or would you rather, because of the time, how would you guys want to deal with it? So first, William, all of this part of the middle school, the American model is different from ours. It is different. I don't understand quite what's behind it. Perhaps is the actual education of the teacher that you cannot ask because the teacher would not know the answer. So in physics, the majority, at least in the South, you're not uh, you're not trained that way. The teacher just would not know. He doesn't have to know. He has 40 hours of work a week, and he doesn't have time. They go, they look, and they like it, but it's informative. It's not um, a thing like that. So this part of sustainability for us, physics scientists or researchers, we are laboratory people, and this is new for us, is to take into account um, the impact in the environment and etc. But we have to think and do it right, because that's not a natural thing. It does not come naturally. So he's not very concerned with the details. So this is the researcher in physics. Now you're gonna train someone with a degree in physics and materials and technology that has to be built in their education, the importance of that. And we are going to make an effort bearing in mind this type of information. I think it's a very interesting initiative. It's one of the ways that we can go over this. And multidisciplinarity, I agree, it's very difficult. How are we going to deal with that? Because universities are disciplinary. You divide it in departments, and you have teachers of biology, chemistry, physics, and you put together this to put together a course. This is not the best solution. In our own education, we didn't have option like this. So nano now are taught by physics professor. You introduce computational chemistry as something extra, but this is physics. Physics scientists, they deal with nano concepts. We cannot do an engineer nano because we don't have support of the university. So this was the initiative of our course. And who would be the teachers in this? Because this epistemological part is important. What are these teachers? Who they are? What's the training? How do you discuss that? So it is a snowball, and we do not know the end of this. Well, there are different ways of dealing with this. But to complement what's being said here, uh, a colleague of mine, he is the coordinator of physics in Unicamp, he's proposing a course of physical engineering. Something like this, you put a few disciplines of engineering with another core, so you have to train an engineer that's more geared toward development. And in the same model, what would be the key disciplines in electrical or mechanical engineering? Perhaps half a dozen, perhaps chemistry engineering, so we can put something more or less consistent. After several months of negotiation, the congregation of the mechanic engineering vetoed the participation of mechanic engineers because they didn't offer 5 seats extra in 3 disciplines. So the level of difficulty of doing anything new is absurd. How can we do something that's interdisciplinary? One of them is to take the professor from that pedestal, the model that he cannot be questioned. How do you do that? You get a discipline to be shared with different teachers of different areas, and then it becomes more difficult. The authority posture of teacher student, because he's going to have a conflict with his colleague because it's a shared discipline. And then we have this discussion starting. How are we going to do this? Something that's not mentioned very much in the areas of technology, but in other areas is commented. That's a problem. It's in your interest. It's in the future. That's synthetic photosynthesis. Photosynthesis. I participated in a symposium 2 weeks ago. Photosynthesis is a problem. It's the most common reaction in this planet, and it has a degree of complexity, great degree of complexity in any scales, be chemistry, biology, molecular biology, in larger scales. Let's go back talking about scales. And recently, we found out that in order to collect a light for photosynthesis, we involves quantic phenomena at that level, which is a big surprise because it's something that would be practically impossible. Now we can suggest a course in nanoscience. You have something basic, but we have a great project for 4 years. You have to propose a model for synthetic photosynthesis that's sustainable. You have to discuss from the beginning ethics, because you have to create something that replaces life. You have to discuss the matter in all the degrees of complexity. You have to do it on top of areas that are not very well known. How can you have a quantic coherence or the great distance? I'm talking about a few nanometers at the room temperature. And you have several proposals of photovoltaic cell. It is a photosynthesis, is in reality, isn't it? Isn't, but you can make the parallel. And what are the proposals? How nanotechnology can use this? You can do a theme that's across the board in different disciplines and put it together with some basic disciplines with perhaps a less time load for the students and the teacher. In reality, we have to escape a little bit of the standards that are already established in university. Because I think we found this sort of thing in Xerém, in Metro, because that's a new center. It's not going to be so divided up in departments. We will have everybody working together. And we do have a project of an extension project with some schools nearby. These are projects in the area of biology, chemistry. So we are trying in Xerém, since we are a little bit further away from the university, we have 32 teachers there, and we are increasing that number. We are trying to do something different. We're trying to do a different model there, and then perhaps we'll be able to fit all of these new possibilities. But we teachers have to think. We have to change. When we started our course, we didn't have anybody to work with the medical part, for instance. But now we know people, we have the contacts, we're going to create new disciplines. Since they are disciplines that are going to be, will be optional, the most difficult is to create a course at first, but when you include new disciplines that are optional, they have to come in as optional, but we have to always increase the list of possibilities. I believe this is the way we should go. And if we manage to escape that bureaucratic structure of the university, the number of seats, no, in this classroom we can't have another 5 students, or a classroom that will have physics for materials, you cannot have it for electronics. Why do they have to be separate? Why can't my student get adapt in that lab? What's the great bureaucracy? What's the problem? We use the computer to create more red tape instead of facilitating things. So all of the theme of administration of let's see if we can escape all of this. Unfortunately, we will have to stop now. The speakers will be here. You can ask questions directly. Because a few speakers in the afternoon, they have flights to return to their homes, so it will be very difficult if we are later than this. I really thank you for your participation, your patience, and at 20 to 3 we'll be back here. Thank you.